So thank you for everybody taking time out of your week for another one of our ongoing CPQ Talk series where we highlight interesting customer stories, cover strategies that leverage CPQ functionality, and introduce key partners to help you in your success. So today we're joined by SoftClouds showcasing a customer story at Carver Pump where they have a unique pump configuration process that uses CPQ and PumpFlo. Now, PumpFlo is an industry-specific pump selection software that uses various input conditions to provide pump operating efficiencies and characteristics, and I think you'd be really interested in the demo. The Carver CPQ implementation is likely a global first and provides Carver with a unique differentiation factor, which is ever most important. For context, Carver Pump is based in Muscatine, Iowa, and is a global leader in centrifugal pump technologies. They build pumps for some of the most demanding engineering specification and military standards in the world. If you go to practically any industry that moves fluids, Carver Pump is behind it. SoftClouds is an Oracle CX technology expert and platinum partner, and SoftClouds has been delivering sophisticated, unique solutions for more than 13 years. In today's session, we'll provide a brief intro to SoftClouds, then highlight how CPQ Cloud was used to modernize the pump configuration process. But before we get started, a few housekeeping notes. This session is being recorded, and the presentation along with the recording will be posted on the CPQ workspace, which is cpqcloud.info, for anybody who wants to visit that and say what a great place that is. Everyone's on mute until the Q&A session towards the end, but during the webinar, please feel free to use the chat window to submit any questions you may have. And now, allow me to turn it over and introduce Brian Friedman and Shrikesh Menon. Gentlemen.
Thanks, Graham. Really appreciate it. Good morning, afternoon, or evening, depending on where you're based. I'm Brian Friedman, GVP of Global Sales for SoftClouds. We're based in San Diego, so still in the morning for us, but really do appreciate you joining us. So a quick little bit of background on Carver Pump. They have been in business since 1938. They manufacture a variety of centrifugal pumps. And a lot of the work that they do is military grade and government grade. So very exacting standards in terms of how they produce, what they produce, and the final product that they create. You can see the industries that they serve. And what they were finding is that they had and were using a process that had really been developed over the centuries as they, or the decades as they built their business. And about 60 to 70% of the pumps that they create and manufacture are custom quoted products. In other words, there's very few instances where they get an order for a product that's in existence. Everything has some unique characteristics and unique capabilities that are needed for the pump. They use an integration with an application called PumpFlo, which is an industry standard visualization tool. One of the requirements that they had is that we had to integrate CPQ and the CPQ deployment with PumpFlo. Obviously, each pump being custom manufactured required the ability to custom spec and create each pump. And we also had to integrate with another third-party application, which is called Made to Manage. So not only were we looking at the pump configuration in CPQ, but we had a number of third-party applications that we had to integrate with as well. One of the big issues that they had is because the process of quoting pumps was a manual process, it took a very long time, it was somewhat inaccurate, and there was a heavy reliance on tribal knowledge. There's a few people in the organization that understand how all of the parts and pieces come together to create a pump, but in many instances, a salesperson couldn't actually go and create the pump on their own because they had to rely on so many other people within the organization to pull the entire quote together. And as a result of that, they had a number of quotes that were inaccurate and required instances of going back and reconfiguration, requoting, and it really just caused an awful lot of delays, a lack of accuracy, and a significant amount of time. So what we found in reviewing this entire situation is that there were hundreds of unique parameters, and it really created hundreds of thousands, if not millions, of different part numbers and potential configurations. There was no existing list of parts because each individual order resulted in the creation of a new part. And the third-party applications presented a challenge as well. So we needed to create a data-driven framework to build and maintain the rules for pump configuration and come up with a system that was easy enough for the administrators at Carver to be able to use and modify as they went ahead. And obviously, we found, or as we were doing this, that the M2M platform didn't have any open APIs, so we had to create middleware to integrate between CPQ and M2M as well. So I'm going to turn this over to Shrikesh now so he can talk about our solution and then take you through a demo of the product that we created.
Brian, are you? Can you stop sharing? I can pick up from here.
Okay, there you go.
Okay. Hello, everyone. This is Shrikesh. So, So as Brian mentioned, based on our analysis, we found that it should be a seamless integration, and they would need a single application through which they can do the selection of the pumps and then create an order and push it to M2M, which is their ERP system. So what we did is we used web services to connect to PumpFlo, and in the process they would be able to select those parameters based on which the initial pump selection would happen. And once the pump selection happens, then the configuration process starts. So basically PumpFlo will just point in the direction on which is the right pump for their requirement, and then you can configure and customize those pumps. So CPQ takes care the correct configuration is being selected, and it guides the user through the process. And then we added in other additional things like the testing requirements and preservation requirements and everything, so that the final code can be created. And another unique thing about this solution is that in most of the CPQ implementations, there is a list of products which the customer would be quoting. In this case, there is no finite list of products, because based on each of the parameter, it can result in creation of a new part number. So CPQ not only helps to create those part numbers in runtime and update our database, it also creates the BOM structure in M2M. It builds those relationships and everything, so that in future, if someone has the same kind of requirement, they can directly pick that product. And if there is something new, the system will check on the part database, and based on that, it will create a new product. So I'll now jump into the demo. So we will go through the complete process, starting from creation of a new transaction, selecting an account, and this account information is being synced from M2M. Then enter the initial pump requirements and display the available pump selection. So there is a to and fro integration between PumpFlo to show all the pumps that meet the selection criteria. Then we will go through the process of configuring the operating point. That's again an integration with PumpFlo. And then configure the pump. This is based on the rules that are defined in CPQ. And then we have the approval flow, submission of the order, and which in turn will sync all the parts information. So if it's a new part, it will create a part, the BOM relationship, then it will create an order, add the line items. If it's a new account, it will also create the account, and the complete process would be done in M2M. So M2M would be having the new account, the new order, as well as the part numbers. So they don't have a CRM system like any cloud-based CRM or anything. So all the customer management will also be done through CPQ itself. So they have basic requirement like adding the address and everything. So I'll get started with creation of a new transaction. So once we go to the customer details page, they can search for a specific customer. So all this customer information is being synced from M2M, which is their current ERP system, where they maintain all the customer information as well. And each customer can have like multiple addresses to be selected from. So these are all the addresses which is maintained as 1:M relation. So for each customer, there can be multiple address. So you can select the address. So if you see for this particular account, there are more than like 160 addresses. And I hit on populate. So it will automatically populate all the customer information for that particular quote. So I'll go back to transaction detail and click on add to catalog. And then this is the start of the configuration process. So as you can see, the first part, as we talked in the diagram, the first part is selection of the pump based on the input parameters. So for example, if you need a 50 Hertz or a 60 Hertz pump, what is the engineering unit that you need to use, whether it's English or metric, and then the corresponding pump types. So here using CPQ rules, we are handling this. This is again data driven. Based on the frequency of the pumps, it shows what are the pump types that are compatible. So let me select this one. So once I select the pump, based on the rules, it shows what are the different kinds of models that can be selected. So I'm selecting 2 of those models. And then we have the fluid selection. So just to give you a background on how it used to work before we had CPQ is that anyone who wants to quote for a pump would go to PumpFlo site, and then they will select the fluid details and the design point details and select a specific pump and send that information to the to Carver team. Their pump engineer needs to go through that information, see whether by changing the speed or design point, they can cater to that requirement. And then there is that to and fro communication over mail or phone to finally decide which pump needs to be selected. Now, coming to the CPQ world, what we have done is we have integrated with PumpFlo. So for example, if they need water and if the operating temperature is 100, these values, it will automatically populate from PumpFlo through web service. And we have given all these options of selecting the liquid they want to use in the pump they are going to quote for or order for. So for example, if I am changing this from 90 degree to, let's say, 100, it makes a web service call and it automatically calculates what the fluid vapor pressure is, the viscosity is, the density, specific gravity. So this is more information than what is available in the PumpFlo site. We made it available so that they can make a more knowledgeable decision. Now, this is the part where you actually mention what is the design point, flow unit, design point flow, design point head, suction head, and near miss. So basically, these are parameters based on which you will get a list of pumps from which you can select. And you can also change the unit of measure that is being used. The unit of measure is very critical in case of pump configuration, because all the values would differ based on what unit of measures are being selected. So let's take an example where I put the design point flow as 250, design point head as 150, suction head 0, and near miss as 10, and hit on search. So this again is going to make a call to PumpFlo, and it's going to return us a list of pumps that would fulfill these criteria. So now these are the different pumps that fulfill this criteria. Now using CPQ, what we could do is like we have narrowed down their search based on the model that Carver Pump sells, and the data that is being shown over here is just a subset based on their selection, as compared to how it was where you were not selecting these models and you would get a huge list. Also in this table, you can see we have shown a preview, because this red line, which is the operating point, was very critical for them. So what we did is we added this image. So this is an image which gets generated in runtime, and I'll talk about it, about how these graphs are generated in the next section. So I can select a specific pump that has been returned by PumpFlo. So once I select this, I can go ahead and now customize or change the parameters. Like I can change the speed, I can change the stage frame, horsepower, and everything, and see how the operating point is going to vary based on it. Also, there are options like you can see how multiple pumps would work, how the pump would work in case there are multiple speeds on which you need to make the pump work. So let me just add some of the parameters, and then we will see how the graph changes based on the selections. So I need the resistance curve, efficiency, and for the multiple speeds, I want these parameters. So I select all the parameters that I need to see. And now I need to see what would be the operating point. So if I select, so these are some of the display options where it shows the selection window. So just to give a background, this is the selection window in which the pump would operate, and your operating point should be somewhere in between. And this is the diameter that was requested. So it shows how the pump would operate. And now if I select this particular section, that is to display the design point in the graph, it will make a call to PumpFlo and get the latest graph. And here you can see for this diameter how the operating point looks like, right? So now, as you can see, this graph that we are showing is dynamic based on the inputs that we are sending. So the challenge was we don't get a image file that can be shown over here. We get a bit stream. So in our solution, we are reading that bit stream, converting it into an HTML image, and displaying it in runtime. So that for the end user, it's like directly working on PumpFlo, where they are modifying the parameters and directly they can see the changes. But since we have it in CPQ, it's also governed by the rules that we have written, which is specific to Carver. Like for a specific model, for specific parameters, how that particular design point is going to look like. So it makes the pump selection process easy, even for someone who is not an expert pump engineer. So other things are like I can also show, like if I want to show NPSH, so it again changes the graph. So currently we have the power HP. Now the NPSH is another curve that needs to be added. So here you can see the NPSH curve has been added. Similarly, I can change the speed and see how the graph is going to change. So we have, and then there are certain pumps where you can have more than one stages. So you can even change or add multiple stages and see how the graph is going to change. So coming to the next section, that is of multiple pumps. Let's say I want to see how 5 pumps in parallel with these inputs, how it is going to look like. So as soon as I enter the number of pumps as 5, and when I put show it on chart, then it makes another call and gets the latest image based on these input parameters. So I'll just remove this one. So this is how we have seamlessly integrated with PumpFlo. And here it shows how 5 parallel pumps would be, the graph for 5 parallel pumps, how it is going to be, it would show over here. So for a pump engineer, this graph would make sense, and they would know what are the parameters and how they can use that pump in their working conditions. Similarly, if we have to see how multiple speeds would look like in this particular pump, we can also update the speeds and see the curve for different speeds. So it's a pump which is supposed to operate at 3500. Now, let's say I want to see it at 3200, 3400. And I want to check the chart for this. So based on these input parameters, it's again going to update it. And it also shows how the operating point looks like. So the optimal one is 3500. If it is more or less than that, how the graph looks and whether it would fall inside the operating point or it's going to be outside, that information can be derived from this particular graph. So the whole idea was to have a single place where you can actually change the parameters and then do the pump selection. So the whole page over here, which doesn't look like general configuration of a product, this is a page that we have built specifically to integrate with PumpFlo and give the ability to configure or select the pump. So once this pump has been selected, the next stage is to configure the pump. Now, to configure a pump, there are like hundreds of parameters. But what we have done is we have worked with Carver team and found out for each pump what is the type of parameters that generally is being selected. So generally the pump specification, if it's industrial, generally the fluid temperature would be less than 220 Fahrenheit, suction pressure less than 50 psi, external flush won't be preferred. So we have set these default variables, and they can always go and change these values, but based on these basic information, because they have data for maybe 70, 80 years, and based on that and these parameters, all the various components of a pump is pre-configured. So for example, these are parts of a pump like the unit, the bare pump, the casing kit, impeller kit, bearing frame, flush plan, mechanical seal, motor. So here you can see there is a specific part number that is being generated at runtime. So the reason why we are generating this part number at runtime is like they can change any of these values and this part number will automatically change. So this is not like a typical coating configuration where you have predefined parts. So in this case, if I am changing this particular parameter from, let's go to this one. So instead of open steel construction, if I want the parameter to be changed to a different one, it's automatically going to change this particular part number. And each alphabet of this part number makes sense to the person who is actually manufacturing the pump. So if and at the same time, there may be certain parameters which they have never manufactured or never configured in that way. For example, generally it is done, the unit is created using synthetic fiber. Now let's say the customer wants it to be built on stainless steel. So the system is going to evaluate whether it's a valid part number and if such a part number can be made. And there are certain part numbers which can be made, but generally no customer asks for that part number. So it is being set as a non-standard part number. So here you can see it changes to non-standard. And this particular parameter is used to derive whether it needs to go through a sales engineer to actually evaluate and approve this particular quote. So in our case, the approval of the quote may be based on the discount, but it is also based on the type of part number that is being generated. If it's a non-standard, the system is going to tell it's a non-standard one, and it needs to be routed through the sales engineer. So select a different one. So these are all non-standard part numbers that are getting generated. And here, based on each option that is being selected, the price is going to vary. So since the part numbers are not a finite list of part numbers, each parameter of the part or the way it is being configured is going to change the price. Now, I selected a non-standard. The price became 0.0. It will go for an approval because it needs to be evaluated. And once it has been evaluated, the sales engineer needs to update the price manually. So that's another check that we have put. And this ensures, like, once it has been quoted to the customer, you already have a valid price for that, and that particular solution has been already evaluated before we send the quote document to the customer. So the same logic holds true for the remaining parameters as well. Like if the impeller style, if it is closed, it is CF. If I change it to semi-open, then it is going to be updated as BF. And let's say I want it as an open, then it is not a standard one, so it becomes a non-standard part number. So this is the logic that we implemented. And as you can see, the number of clicks or the number of parameters that needs to be updated, we have kept it to the minimum. So in case there is not many changes, they can directly go ahead and start create the code. So let me go to the next screen. So if we go back to the this particular flow, so we talked about the integration with the pump flow. Then we came to the configuration of the pump. Now this is the actual pump that gets configured. Now if I go to the next node, there are various other things that are tied to the actual pump, like the packaging, whether you want export or special kind of packaging. So based on each of these parameters that are selected, the system is automatically, so these are the constraints that work to tell that for domestic, this particular packaging was valid. But if you want export, then you need to select level 2 or level 3. And here it shows what is the packaging price. Similarly, there are paint standards, and you can select a specific paint standard, or if you want something special, then you can actually put in the comment on what are the paint standards that you want to use. So all this is achieved using rules in CPQ. Then there is a list of tests that can be done. So by default, they do test it, but there is no test plan, witness, or a report that is generated. Now, if you want to make certain changes, let's say you want a review to be added, it automatically updates the price. If you need an inspection, it again updates the price. So each attribute selection that we are doing in this configuration window is updating the price. Same holds true for compressed air or leakage test or hydraulic performance test. So everything is data driven, and we have tables that has been maintained where based on these selections, it automatically evaluates the price and updates it. Also, moving from testing, next we reach to the preservation. So by default, there is nothing that is added as a preservation. So if you want something special or specify, so if I select as specify, I can add the comments. But let's say I select specify here. These are the different preservation standards that can be added. And adding any of these will automatically update the corresponding price. Now, next, once okay, so next is based on the selections that the customer makes, system automatically selects what are the flange orientation that can be selected. So that's this small section over here in the diagram. And you can select the way you want it. So over in the down or the right side up. So these are the various options that can be selected. So we are giving those visual indications based on which the customer can make their selections. So all this part that we are discussing currently was not available initially. So we have put all the rules in CPQ, and we have kept it data driven so that based on the selection, the complete pump, each and every part can be configured using CPQ. And since we have those rules defined, it ensures like a wrong part number or an inaccurate configuration cannot be created. The other thing we added is adding auxiliary equipment. Now, there may be certain things that is in addition to whatever needs to be configured. So here we have used an array to capture all that information. So this is the table where you can put a test equipment and update the corresponding price. Let's say 2000. And this is dynamic. So if you want 3 auxiliary equipments, you can add 3. If you just want 1, you can just update it. And the system just shows the 1 equipment that needs to be configured. And here it adds all these parts. So you can see this particular part is non-standard. This particular motor is non-standard. The rest of the things have been added. So it gives a visual indication on what are the actual parts that are non-standard and that needs to go for an approval process. So now I will add this to the transaction. So this completes our configuration of the pump. Now, since some of the parts are non-standard, it will be routed for approval, and they can directly go and add the actual price. And that will automatically update the total contract value. So let's see.
While you're doing that, Shrikesh, just to a time check, we've got about 25 minutes left, and we've got a whole bunch of questions rolling in.
Okay. Yeah, so I'll move to the next last section and the document, and then we can take the questions. So once this pump has been configured, next is the quality. So the quality standards, there was no way to actually capture this information initially. So we provided a simple structure where if it is for example, if it's non-destructive test, you can either go for the standard one. And the standard one, if you click here, it tells you what exactly is done in non-destructive test as a standard one. If you want something to be changed, for example, you want a non-standard one, you can select non-standard. you can specify the information. So basic information is already there. You can add in any additional information that needs to be put. So on and so forth. So you can imagine with pumps with lot of parameters, like there are different tests and you have different combinations that you can select. I'll just go through this last one. And as you select these values, if it is being priced, the system will automatically update the price as well. So this is where the quality is being selected, right? So this way we use the commerce section to provide a simple interface where they can put in all the details regarding the quality test that needs to be done. So the document, again, it was not a straightforward document that they wanted. They wanted to customize the document. So in the initial code, they just send the line item details. Then to the final code, they want the cover letter. They want something custom to be written. So we have given it as a completely configurable section. So data sheets, anything that needs to be added, the user can select it. If there is any image that needs to be added, that can be added. If any exceptions needs to be specified, that can be added over here. And the proposal that gets generated will also get the final graph that we had selected. So based on that, it will generate the complete code document. So I can just go to So this is a document. So these are the different sections that were added, and this is the breakdown of the price. This is the performance curve and the graph they initially selected. This is the image. So everything is customized or configured as per what the sales engineer wants to add. And we have kept it completely customizable for the sales engineer. Then we have the regular process of giving the discount, and those are the regular CPQ functionalities like percentage off, amount off, or a price override. And this is the total contract value. So I'll not submit this because we are connected to their M2M system, the production one. So I don't want to submit this particular code.
So I got a question, Shrikesh, while we're talking about it here. The intended user of the demo that you've just run through, I believe that's for the end sales user, isn't it?
Yeah.
Okay. And then we had a related question that came from Lisa Kelly, who's working on an opportunity now doing channels. Is this, or is the plan to expose this to Carver's channel partners?
Yeah, so the plan is, in the pilot phase, this thing is also enabled for the partners. So they can actually create their, so we have created partner organization, and we have the channel partners can also create a code. We don't give the ability to submit the order, but the code gets created and it gets routed to the sales engineer in Carver. So for them, they have the complete quoting functionality already implemented. They don't have, so it goes through an approval, and they don't have the ability to actually create an order. So the idea is like in pump manufacturing, there would be multiple partners, and they would also be quoting along with Carver. So currently, they just select the pump and then they need to work with the pump engineer. Going forward, they can create a final quote and then give it to the pump engineer, because all information can be captured here.
Okay. I'll save the rest of the questions till you get to the end.
Yeah, so this is the last stage where we created the code document and then submitting the code. that will actually create the order. So as I said, it checks whether the system already checks whether the part is already existing in M2M. So here it says the unit configuration exists, but all these parts are unique parts that has been configured. So the system already gives an indication that these needs to be created as a child of this particular part in M2M. So our middleware takes care of creating the BOMs and the BOM relationships. So BOM is like each part needs to be created in ERP, and it is related like it has the main unit configuration and then the child parts. So all that relationship would be built in M2M.
So one of the questions, just jumping in here, is the customer at all concerned about the proliferation of part numbers at this point? I mean, as an engineered to order solution, the answer is probably that's a good problem to have.
Yeah, so
go ahead, Shrikesh.
Yeah, so basically their expectation on each pump that they manufacture, they are aware, because it's a pump manufacturing, and they are aware like 60% of the business comes from these custom parts that are being created. So based on this information, they can go ahead and build the parts, but the nature of business is that all of these would be custom, and off the shelf would be like 30 to 40% business would come from off the shelf parts. And what this solution also does is like it also creates a repository of off the shelf parts. So once this has been created, if someone else has the same configuration, it will automatically set it like it's an existing part. So it doesn't recreate those parts.
The other thing that we did here too is we created a number of typical pairings of parts and pieces. So in order to reduce some of these parameters, we said typically when someone selects this, the following things go with it. So although everything is customized, we're using some underlying logic to say, this is how it usually is. If that doesn't fit your needs, you can change that. So we're starting to reduce some of those parameters as well. So Shrikesh, do you have anything else on the demo that you'd like to show?
No, because I won't be able to show the M2M. So this would be the last section where we create the final code.
Okay. Why don't you give me back the presenter rights and I'll go back to the end of the deck.
This leads right into Brian's next slide, and everybody's asking impact. What has been the impact to the customer? Primary benefits seen, that sort of question. So Brian,
Sure.
leads right into your next slide.
Thanks for the question, Graham. I appreciate it. So really what happened here is that we were able to create for Carver a single system for pump selection and configuration. As you can see, what they were doing and what they are doing is extremely complex with infinite number of potential possibilities and parameters. So a lot of this required us to take all of these different parameters and start to say, we know in your day-to-day business, all of these things don't always go together. And there are a number of situations where selection of X creates the following 10 part pieces. And we started to pull those things together. For them, that knowledge, that piece of information was basically tribal knowledge. There were people within the organization who knew instinctively that certain selections created certain other selections, but they had no formal method of quantifying how that was happening. So a good deal of what Shrikesh and his team were doing through this process of configuring CPQ for Carver was to gain an understanding of that tribal knowledge, and then also to force Carver internally to validate that the things that they were telling us were in fact true and replicable. So a lot of this took a significant amount of time because this was a huge transformational project for Carver. But the end result, as you can see, is the elimination of a tremendous number of variables in the creation of a pump and the configuration of the pump. The other thing that it did, obviously, was it created quote accuracy and guardrails on configuration. So we have a system that in certain instances, CPQ will tell the individual configuring a pump, no, you can't do that. You either can't do it because PumpFlo will show that it's going to go outside of the necessary parameters, or that they are not parts and pieces that go together in the full configuration of a pump. We also reduce the quote time by 50 to 60%, which is huge for the way in which Carver operates, and obviously for the growth of their business. One of the questions I saw is, how long did this take to implement? The process itself took about 10 months for the first phase of the implementation, another 3 months for the second phase of the implementation, and then phase 3 is really going to address the last point on this page, which is, as Shrikesh pointed out, to open this up to partners to enable them to use a portion of the system for self-quoting. They won't be able to actually do the pricing because that needs to be validated. The configuration and pricing needs to be validated by Carver, but it will open this up to the partners. So that's pretty much the story of what we've got. I'm not going to spend much time. I see we've only got about 10 minutes left, but just very briefly, we are based in San Diego. We cover the full CX stack. You can see that we do everything from engagement cloud, CPQ, marketing cloud, knowledge service, etc. We have a number of enterprise and major clients that we work with, and we have referenceable industry experience. So I'm going to toss it back to you, Graham. I think the questions are probably more important than talking about us.
So I do have a question, because it's kind of intriguing at this point. You're completely changing the way a company does business. When you approach it from that perspective, the improvement in the quoting time is a nice metric, but there has to be some dramatic improvements and benefits for the business that they achieved from deploying CPQ, both from a cultural perspective and being able to look at it from a top-down and exercise some more efficiencies in the decision-making process. Did you find that true?
Yeah, definitely. One of the things that came out in the course of this, the COO, who was our primary point of contact, came to me at one point and said, you know, I'd never really thought of this, but he said, if I got hit by a bus tomorrow, I don't know how we'd be configuring pumps the next day. And I think part of what happened here was it just became so much a part of the culture that people would go to 1 or 2 or 3 individuals in the organization to validate and configure these significant pumps, that they got to the point where it just wasn't really, it didn't seem to be a situation that they were concerned about, even though it was just happening on a day-to-day basis. So huge cultural shift. We also forced them in the course of all this to really examine their method of doing business. And as such, I think they saw the inefficiencies, and we helped them get to a point of being much more efficient in the way that they were doing their business. Shrikesh, do you have anything else to add to that?
I think, Brian, you covered everything.
So let me ask a question as it relates to the end user. So what's the sales team? What's been their response to this? Is it to roll out? So the first question is, when did it roll out? And then how has the response of the sales team been?
The rollout actually took place in a couple of phases. We did an internal rollout that was about 4 months ago. And that was really when we went from the 2 or 3 sponsors to the broader sales organization to allow them to test and validate and determine how the entire system worked. Shrikesh, can you just kind of speak to what the reactions you were getting as the system did start to roll out?
Okay. From the sales team, like during the implementation process, what we did is like the sales team was always involved during the demos and whenever we were doing requirement captures, and we used to demo the system continuously throughout the duration of the project. So they were aware of how the system works, and based on their inputs is what we started building or designing. The usability was specifically uh, built taking care of how they want to use the system or what would make their life easy. So when we rolled out the system, they were happy with it, and there are a lot of other suggestions from the usability perspective. Certain attributes we have kept, they told we can hide those things, make the UI less number of fields and stuff. But the whole process of configuring, and also there was a feedback from one of the partner from whom Mark took a feedback, like they told this is the best configuration for pump that they have seen. It's not like an off-the-shelf pump they are selecting. They have the complete ability to configure based on the user requirements. Because one of the concern they had initially is like when a customer says like they want to change certain parameter, the sales team may not be aware like whether it can be done or it cannot be done, and they need to get in touch with the sales engineer or the pump engineer. So that has been eliminated to a broader big extent, because here we only show the parameters that can be selected. So that's how we have put those guardrails, and that has helped the sales team.
So have you heard about sales increases that have resulted from this deployment? I mean, because it seems to be giving them capabilities to quote 24/7 instead of just within the 8-hour window that sales engineers are available. Has to have had an immediate impact.
We do know that their sales went up about 25% in 2018, and they're looking at a minimum increase in 2019 of 15 to 20%. Obviously, you know, as you point out, Graham, part of this is due to the fact that they have higher degree of accuracy, a lower time to quote, and then the next phase of the rollout, which is to make this available to partners, basically enables them to be operating and taking quotes 24/7.
It's interesting. So from my perspective, then I would say that Carver is in a very unique position in their industry that has been enabled by this particular solution and the way you've deployed it. So congratulations.
Thanks. Yeah, it is a very unique solution, and truthfully, it's quite replicable because although PumpFlo is an industry standard in the pump manufacturing industry, there are similar types of third-party products in other engineered-to-order industries that could deploy a very similar model to the one that we've done with Carver.
So on that topic then, just asking the question because every salesperson on this call is going to ask it, how many PumpFlo existing customers do you think there are that would be interested? And then the other question that you've just touched upon is, what other industries do you think that this would apply to?
Sure.
I mean,
Shrikesh,
give us a hunting list.
Sorry. Shrikesh, do you have any idea of how many companies in the pump configuration industry use PumpFlo?
So I don't have a number for that, but most of the pump manufacturing companies like Flowserve, or there are a few of those companies who use PumpFlo for pump selection. I mean, it's one of the most widely used tool by pump manufacturing companies.
And to our knowledge and what we're told by Carver is that they're not aware of any other company that has integrated a CPQ solution to PumpFlo. So, you know, we do think we've got an industry-leading solution that we've created for them. And I know that, you know, Shrikesh and I have looked at other opportunities where other engineered-to-order third-party software could be integrated into CPQ to do something similar.
Cool. So Everybody that's on the call, I want to thank you for your time today. You can see on the screen how do you contact Brian and SoftClouds, and let you know that there are 2 additional CPQ talks scheduled with SoftClouds coming up in the next few weeks. One of them is on Emser Tile and I believe Seacoast Medical. That's kind of flexible and may change. But I do want to say thank you to Brian and Shrikesh for your time, and tell you that I thought it was a well-spent hour of the day. I learned something, and I appreciate you taking the effort out to share it with the team.
Great. Thanks so much for the opportunity. Thank you all for joining us, and hope we can get an opportunity to talk about this and some other opportunities together.
Cool. Thanks, sir.
Yeah, thank you.